So far we have gone over motion in 1D. So now we are going to move to motion in 2D, which is what we call a projectile. So projectile is, imagine that you have a particle or you have a ball and you throw it with a particular velocity at an angle to the horizontal over the vertical. So it is probably going to make a path like this. So if you assume that this is the ground level, it is going to hit the ground somewhere there, right? So this types of motion is what we call a projectile, and we call this path as a projectile path. And to be specific, this is going to be a quadratic equation. Let's not worry about that, but understand that it is a projectile path and it is symmetric about the highest point. Right? So before going into the projectile, I would like you to, I want you to remind a concept which is called components of vectors. So what are components of vectors? So components of vectors. So we know what vectors are. Vectors are physical quantities that have magnitude and direction. And in some instances, we might end up with a vector at an angle, which is theta, to the horizontal. So that's a vector V. So what I am interested in finding out is that what is the horizontal component of it and what the vertical component of it. So we mark it as VH and VV. So if I wanted to, for new people, tell you, like, let's say you have your house here and you have your school there, but instead of going straight, right? Maybe say, let's say the road is straight and you're going from your house to the school. So let's say we can plot this in an XY coordinate system, right? So we can plot it in an XY coordinate system. And we can say that this person has moved horizontally a distance of delta X, and he has moved a distance of delta Y in the vertical direction to reach the final destination. And this delta X and delta Y, we call them projections in math, right? Vertical projection and horizontal projections. In physics, we call them as components. So those are the vertical and the horizontal components of a vector, right? So in order to find the vertical and the horizontal component of a vector, all you have to do is you have to have the vector and you have to construct a right angle triangle having that as the hypotenuse side. So once you construct the right angle triangle, so this is the vector that you have, and that is your vertical vector and that is your horizontal vector. So I have seen some students marked it wrong, like some have drawn these like this. So how to correctly get the direction of the vertical and the horizontal vector? So this is your starting point, right? And that's your end point. So you have to start drawing the component vectors, and it should follow one after another, but you have to start it at the starting point of the actual vector and you have to end it wherever the actual vector ends. So this is going to be your horizontal vector and you have to follow up with your vertical vector. That is going to be that. So that is going to be a vertical vector. So now that we have constructed the vector triangle, we can write the equation for sine theta, which is the opposite side over the hypotenuse side. So opposite side is vertical vector component divided by the hypotenuse side, which is the actual vector. Meanwhile, I can write cos theta, which is the adjacent side divided by the hypotenuse side, which is the horizontal vector divided by the actual vertical vector. So just by rearranging this equation, I will get the vertical vector as actual vector times sine theta. And I will get my horizontal vector as actual vector times cos theta. But don't just take these equations for granted, because if the angle is given with the vertical, say alpha, then they will switch, because now you have to draw a right angle, construct a right angle triangle like that, not this way. right? So don't take this for granted, but remember that if the angle is making is with the horizontal, it is going to be sine theta the vertical and the cos the horizontal. But if it is making an angle with the vertical, then it is the opposite. Now going back to the projectile path. So we are throwing a object at a particular angle with the horizontal. And as we can see that this object is moving in the upward direction initially. After it reaches the maximum height, it is moving or coming down. Meanwhile, it has also transported in the horizontal direction as well. So it has two directional motion. That is why we call this as 2D motion as well. So projectile motion is a 2D motion, right? So we can project the motion of this particle. So the horizontal is simple. So you start off here and imagine that this particle is here. You drop a line. This particle is here. This particle is here. You drop it. You have here and you drop it. You have here and finally here. You have it here. So the horizontal is just a straight line. So the particle has moved in a straight line for the horizontal projection. But in a vertical projection, initially it is here and you go here, it is here, and at the maximum height it is somewhere there and it is coming down. So it is going up and coming down, right? So that is your vertical projection. So we will deal with this separately and with the horizontal projection separately, right? So that is going to be a horizontal projection, right? So these are the very basics of the projectile and what a projectile is. And now we will construct the equations and we will understand how we can use the kinematics equation in projectile.